Okay, so what we have going on here is a man on an elevator, and he has a mass of 109 kilograms. The elevator has an upward acceleration of 2 meters per second squared. So what we want to try and do is find the normal force exerted on this man by the elevator. And once again, the normal force is going to be kind of just like a contact force. So for example, this man right here is touching the elevator. So the elevator is exerting an upward force to counteract his weight. And again, his weight, of course, is going to be his mass times gravity, and that's going to be downward. So in order to find the normal force, we're going to use Newton's second law, force equals mass times acceleration, to combine all the forces going on this elevator and equate them to the mass times acceleration. So what we have, let's just go ahead and label the forces acting on the man. So of course, downward force will be his weight, so mass times gravity, and the upward force will be his normal force. Now notice that you may think that the force normal, if you set this up, should be equal to the mass times gravity. And sometimes that is the case, but in this example, we have an acceleration of 2 meters per second squared. So the elevator is moving. Therefore, the force normal is not equal to the mass times gravity because there is another acceleration. So what we want to do is, let's just take the sum of all the forces in the y direction to be equal to the mass times acceleration, and the sum of the forces in the x direction to be equal to the mass times acceleration. Now notice that we don't have any forces acting in the x direction. They are just in the y direction. So we don't even have to use this. We will just use the forces in the y direction to be equal to mass times acceleration. So when we do that, we're going to just add up all the forces. So the first force is the force normal, and notice that this force is positive because it's pointing upwards. So we're going to say that the force normal is one of the forces. The next force that we have is his weight, and his weight is pointing downwards, so I'm going to consider that to be a negative force. So I'm going to subtract mass times gravity, and since I don't have any more forces acting on him, I am going to equate that to mass times acceleration. So we followed this formula right here. We did the sum of the forces, and that is equal to the mass times acceleration. Okay, so now what we want to do is solve for the normal force. So we can move this mass times gravity over to the right side, and we'll end up getting that the force normal will be equal to mass times gravity plus mass times acceleration. And all we have to do is plug in what we have given. So we have our mass given, so 109 kilograms, times gravity, and notice that this will be positive since we moved it over to the right side. If it just stayed here, then this whole term would be negative, but we moved it over to the right side, making the term positive, so therefore the acceleration due to gravity will now be positive. And then we're adding on the mass, once again, times the acceleration of the elevator. And the acceleration of the elevator is 2 meters per second squared. So it has an upward acceleration, so that will be positive 2. And then when you go ahead and solve for that, you're going to get that the force normal is going to be equal to 1,286 newtons. And the way that you can tell if it's going to be newtons is because the force is equal to mass times acceleration, where mass is in kilograms and acceleration is in meters per second squared. And a kilogram times meter per second squared is equivalent to a Newton. So there you have your final answer with the acceleration in the upward direction, and you found your normal force.